A resonant pulse chopper. A resonant pulse chopper is also a thyristor chopper. The circuit is as shown in the figure. As soon as the supply is switched on, the capacitor is charged to a voltage Vc through LM-D1 and load. Now, the circuit operation can be divided into 6 modes. Mode 1 begins when main thyristor T1 is fired and the supply is connected to the load. And this mode is valid for the time t equals to kt, that is nothing but turn on time. Source current flows through the T1, then the current I T1 will exist, the voltage VT1 will be 0 and output voltage V0 equal to Vs. Mode 2 begins after t equals to kt when the commutator T2 is fired. The commutation capacitor reverses its charge through CLM-T2. The reversal current is given by IR equals to minus IC, which equals to Vc square root of C by Lm sine omega mt, which is nothing but the peak reversal current IPR of sine omega mt. Question number 1. And the capacitor voltage Vc at t is given by Vc cos omega mt. That is equation number 2, where omega m equals to 1 by square root of lmc. So after time t equals to kt plus tr, where tr equals to pi root lmc, the capacitor voltage is reversed to minus Vc. However, the resonant oscillations continues through diode D1 and thyristor T1. The peak resonant current Ip must be greater than the load current Im. And normally, the circuit is designed for the condition Ip divided by the load current Im is equals to 1.5. Now mode 3. Mode 3 will begin when T2 is self-commutated and the capacitor discharges due to resonant oscillations through the diode D1 and T1. This mode ends when the capacitor current rises to level of Im, assuming that the capacitor current rises linearly from 0 to Im and that the current of thyristor T1 falls from Im to 0 in time Tx. The time duration for this mode is Tx, which equals to Lm Im by Vc. Let this be question number 3. Now, the capacitor voltage falls to some other level. Let it be V1 equals to Vc minus Tx Im divided by 2c. That equals to Vc minus Lm Im square divided by 2c Vc. Let this be 4. Mode 4 begins when the current through the thyristor T1 falls to 0 and the capacitor continues to discharge through the load at a rate determined by peak load current. Then the available turn-off time T off equals to V1 voltage across the capacitor C divided by Im. Let it be 5. Now the time required for the capacitor to recharge to the supply voltage Vs is given by Td equals to Vs C by Im. Let this be 6. Now the total time to discharge and recharge to the supply voltage from V1 to Vs is commutation time Tc equals to T off plus Td. 7. Mode 5. Mode 5 begins when the freewheeling diode Dm starts conducting and the load current decays through Dm. The energy stored in the commutation inductor Lm and the source inductance Ls is transferred to the capacitor C after T equals to Ts. Ts equals to pi square root of here Ls plus Lm of C. The overcharging current becomes 0 and the capacitor is recharged to Vx, which equals to Vs plus delta V. Let this be question number 8. Then delta V equals to Im square root of Lm plus Ls divided by C. Let this be 9. Mode 6. Mode 6 begins when the overcharging is complete and the diode D1 turns off. The load current continues to decay until the main thyristor T1 is refilled in the next cycle. Equivalent circuit, it's Dm combination with the load, and the current flowing through this is Im, which is going to decay until the T1 is fired. These are the 6 modes involved in resonant pulse chopper.